story.
Yes, please.
So start it.
Okay.
Okay. So, good evening, everyone. This group nine members, and we are presenting on input-output systems of computer organization and computer architecture. So, I'm Bright Adiba.
I am Emmanuel
My name
Daniel.
I'm Ankabeidi Joseph Kingsley.
I'm
Latifah
Cyril
Musa.
J. John Fiat.
Nanakusi Asante.
Okay, so as we continue, we'll start with introduction of input and output systems. So, when we talk about input systems, they receive signals they receive signals entering the computer, and examples can be the keyboard and sensor. Sorry. And when we talk about the output systems too, they bring out information from the computer, or they display information which is going on in the motherboard. So devices which display the informations can be a printer and a monitor. So the core purpose of in- input and output systems is that they act like bridge between the CPU memory and external devices, and also they enable human machine interaction and data storage. And these are examples of input and output systems. So input devices, we have keyboard, mouse, scanner, microphone, camera, and sensors. And output devices, we have monitor, printer, speakers, and actuators. And we have hybrid devices, which is the touch screens, USB USB drives, and network card. And the last is visual, which is collage of input and output device icons.
Okay, so my name is Nanakusi Asante. We are now looking at the input/output interface. The role for the input/output interface is to resolve differences in the voltage or timing and also data in the format between the CPU and then the input and output devices. This input and output interface has components, one which is ports. The port is the physical connectors such as the USB or the HDMI. And the second components are the controllers, which are the hardware managing devices communication. Examples are SDA, then PCOE. The third component are the registers. Under the registers, we have data, entry, and settles registers. Thank you.
So my name is Latifah Mustafa, and on our next presentation we have input output buses and protocols. So input output buses and protocols are basically the data, the roads they are beside the computer. And for the bus types, we have system bus, which is the CPU memory communication, and also the input output bus, which is we have an example of the input output bus is the USB and the Thunderbolt. And then for the protocols, we have parallel, which is multiple wires. Example, PCI. And also we have serial protocol, which is single wire. And its example is USB. Thank you.
Um, Emmanuel, you
Okay.
should continue with the input output techniques. Cyril.
Okay, my name is Cyril J. John Fiat. I'm going to take you through the input-output techniques. So first, we are going to talk about the programmed input-output techniques. So first, you have the CPU pool device. That is the constant checking, and then we have some pros and cons. Some pros is they are simple, and then the cons are CPU ineffective. And then secondly, I'm going to take you through the interrupt driven input output. Device alerts CPU via interaction. And I have some pros and cons here. That's the CPU free,
So
the free
I'm
keep,
recording something.
the CPU free until needed. And then the cons is overhead for small data. And thirdly, I have the direct memory access, that's the DME. I have the dedicated controller transfer transfer data without CPU. And then the pros and cons. The pros, I have high speed bulk transfers. And then the cons is complex setup. Thank you.
Well done. Um, Joseph Bailey, can you please continue with the input output performance?
Okay, so I'm Kabedi Joseph Kingsley, and I'm talking about the input output performance matrices. So the first one is latency. Latency is the time it takes for data to start moving from the source to the destination. Think of it as the waiting time. Two, the throughput. The throughput measures how much data is transferred per second. For example, if you are downloading a file and it's moving at 5 megabytes per second, that's your true output. Two, three, bandwidth. Bandwidth is the maximum amount of data that can be transferred per second. It's like the width of a highway. Four, overhead. Overhead is the extra work for the CPU. Is the extra work the CPU has to do to manage the input output. For example, every time data is read from a disk, the CPU needs to coordinate that, and that consumes processing time, which could otherwise be used for running your app. And the last one, we talk about the patching parallel input output. To improve input output performance, we use techniques like buffering, where data is temporarily stored to handle speed differences. Thank you.
Emmanuel, can you please deal with the real world applications for us?
So for the real world applications, in real life, input output systems are used in storage, networking, video, video rendering, and Internet of Things. Think about SSDs being faster than HDDs or hard disk drives, or how your smartphone devices send and receive information constantly as compared to the native letter writing and stuff. Thank you. Now for challenges and future trends. Right. The next slide, please.
Please continue with the challenges.
Okay. So input output systems, they face challenges like bottlenecks in high speeds high speed systems, which means uh, faster computers have input output systems have a harder time running fast in high running computers, and they also have problems with security. Future trends include using light for faster data, brain computer interfaces, and even quantum computing. The next slide, please.